Hi everyone, I'm here with your 122 lesson, How Can I Solve the Proportion? Strategies for Solving Proportional Relationships. Proportional relationships can be identified in both tables and graphs. In the last lesson, you also used both of these representations to make predictions about proportional situations. Today, you will continue to develop strategies for solving proportional situations using an equation. Kenny can make 7 origami folded paper cranes in 10 minutes. He read a story about a girl who could make 1,505 cranes, so he was curious how long it would take him to make that many without stopping. Complete Kenny's table below and then explain how you did so. How many minutes would it take to fold 1,505 cranes? How many hours? So go ahead and work on that table. Okay, if you're back with me, you've completed the table, and there are many ways that you could have done this, but the way that I looked at this is I wanted to figure out the unit rate. So, I'm sorry, not the unit rate. Take that back. 1,505, 7 origami. So she made 1,505 cranes and he made 7. So we're going to divide those and get 215. So 7 times 215, if we just need to double check that, would be 1,505 cranes. So that's what he wants to make. So it takes him 10 minutes to make 7 cranes. So it would take him 10 minutes, and we have that 215, which would be 2,150 minutes. But if we wanted to figure this out in hours, we would need to take that and divide it by 60 because there are 60 minutes in an hour. And we would get 35 and 83 hundredths. The three repeats, so it would really take him at least 36 hours. But we're just going to say that. Okay. B said, instead of solving this problem using a table or graph, Kenny represented 7 cranes in the 10 minutes as 10 minutes to 7 cranes. Then he wrote an equivalent ratio as follows. 7 minutes for 7 cranes equals blank minutes for 1,505 cranes. Use 2 different strategies to find the missing value in the equivalent ratio. So go ahead and use 2 different strategies. Okay. Your strategies could vary, so I'm not going to sit here and go through them, but you still should have gotten the same answer, 2,150 minutes. So we're actually going to flip over to the back and we're going to break down some of these strategies that you could have used so you feel more comfortable with them. 153, multiple strategies. Kenny's class found several ways to solve 10 sevenths equals x over 1,505. 3 of these strategies that they used are presented below. Some of these strategies might be the same as what your class did in problem 152. However, others may be new. Work to understand each strategy so that you can use it to solve a new problem. Giant 1 method. Multiplying a ratio by 1 does not change the value of the ratio. You can write 1 in many forms, such as 3/3 and 14/14. In this course, this kind of fraction is called a giant 1. Find the value to use as the numerator and denominator in the giant 1, and then find the value of x in the equation below. So go ahead and try to just find the value that's going to go in the giant 1. Okay. In the giant 1, hopefully you came up with 215 because we used that back in that first problem. And if we multiply 10 times 215, that's going to give us 2,150. So the goal was to look for something that multiplied by 7 that will equal 1,505. So we could have done 1,505 divided by 7. That gave us our 215. So that's what we needed it as the giant 1. Okay, so here x would be 2,150. B, undoing division. In this ratio, x is divided by 1,505. You can undo the division by multiplying each side of the proportion by 1,505 like this. 1,505 over 1 times 10 sevenths equals x over 1,505 times 1,505 over 1. Work with your team to explain how this strategy works. Are the two ratios still equal? Why are both sides multiplied by 1,505? Simplify each side of the equation and find x. So go ahead and solve that and answer those questions. Okay, if you're with me, you have done that. So we're going to talk about this. The ratios are still equal because we changed both sides the same way. Both sides end up being multiplied by 1,505, and then x is divided by 1,505. So if we take a look at this, we're going to multiply across here on both sides. So we have 1,505 times 10, and that's going to give us 15,050 divided by 7, because 1 times 7 is 7, equals 1,505x over 1,505. So these actually, because they're the same, we can just go like that. So that means on this side, we just have x, and then we would divide our other side by 7, and we get 2,150, which is the answer that we are looking for. Moving on to C, the fraction buster method. And we will have a lot of practice with the fraction buster method this year. If multiplying both sides by 1,505 to get rid of the denominator of x, then you can use the same strategy to get rid of 7 in the other denominator. Discuss this method with your team and decide if undoing both denominators is a reasonable strategy. How does using this method help you solve the equation? What else do you need to do to find x? So go ahead and answer that question. Okay, if you're back with me, then you have answered these questions. First of all, yes, both sides can be multiplied by 7 and 1,505 because this eliminates the fractions. So if we take a look at this, over here, it's kind of hard to see. When we're multiplying, these 7s and these divide to just give you 1. So that's why over here we have 1,505 times 10 and x times 7. So this is much simpler for us to solve than with all those fractions. And this is kind of like the last one. So we have 15,050 and 7x. Now it's just a simple one-step equation. We would solve by dividing by 7, and we get 2,150, which equals x. So those are 3 methods that you can use to solve these. And truthfully, it's whatever one that you feel most comfortable with. So 154, use each of the strategies from problems 153 to solve the problems below. When he was little, Miguel could not sleep without his Captain Terrific action figure. It looked so lifelike because it was a perfect scale model. The actor who plays Captain Terrific on television is 216 centimeters tall. Miguel's doll is 10 centimeters tall. If the doll's neck is 9,300 centimeters long, how long is the actor's neck? Use the undoing division method to solve this proportion. So it wants you to use undoing division. Go ahead and try. Okay, if you're back with me, you have tried. So we have 216 over 10, equals x over 9,300. We're going to multiply by undoing division. And when we do that, that's going to give us so 206 times 9,300 is 288 hundredths divided by 10, which gives you 20 and 88 thousandths equals X. So if we were round to the nearest tenth, that's going to give us X equals 20.1 centimeters. B, the Northwood School Math Club is having a tamale sale. The school has 1,600 students, but the club members are not sure how many tamales to make. One day during lunch, the club asked random students if they would buy a tamale. They found out that 15 out of 80 students surveyed said they would definitely buy a tamale. How many tamales would the math club expect to sell? Use the fraction buster method to solve the proportion. 15 over 80 equals X over 1,600. So I'm going to copy it. Go ahead and pause the video and try. Okay, so we're going to look at this. 15 over 80 equals X over 1,600. So we're going to multiply this side by 1,600 over 1 and 80 over 1. And we're going to do the same thing over here. 80 over 1 and 1,600 over 1. So that gives us 1,600 times 15 equals 80x. 1,600 times 15 is going to give you 24,000 equals 80x. Again, simple one-step equation now. Opposite of multiplication is division. So we're going to divide both sides by 80. And we're going to get 300 equals X. So we would need them to make, they should expect to sell 300 tamales. C, on the school copy machine, Mr. Douglas reduced a triangle so that it would fit better in the student portfolios. The shortest side of the original triangle was 22 centimeters. Other measurements are shown in the diagram. How long was the longest side of the original triangle? Solve the proportion 22 over 8 equals X over 12 using the giant 1 method. So go ahead and use the giant 1 method. Okay, if you're back with me, you have used the giant 1 method. So we're going to take these two sides and divide them to get 1.5. 1.5 is going to be what's in our giant 1. So we have 22 over 8 times 1.5 over 1.5. So 12 is going to be your denominator. And once you multiply, we would have 33. So X would be 33 units. Finally, problem 155. Elise is starting a recycling club at her school and hopes to use the money earned from recycling cans to buy recycling bins for the school. Elsie, I might have said Elise, needs to figure out how much the cans that can be collected at her school weigh. So she starts by weighing the cans in her recycling bin at home. She finds that 50 cans weigh 0.8 kilograms. The next day, Elsie counts that cans at school and finds that her fellow students throw away 1,240 cans each day. Solve the proportion below by using any method of your choice to find out how much of all the school's cans weigh. So go ahead and use any method that you want to solve this proportion. If you're back with me, you have solved the proportion. Again, it could have been any way you wanted, but your answer should have been 19 and 84/100 kilograms. And you could have actually solved it all 3 ways and got the same answer. If you have any questions, please ask us, but that is it for today's lesson.